Okay, good afternoon, everyone, once again. So let's see the problems of homework. Okay, right? So today we are going to discuss the problems of 10.1, 10.2 homework so that you can clear all your doubts before starting new topic, because new topic, which is viscosity and surface tension, that is completely different from this topic. Okay, that is completely different from what we have studied in point 1 and point 2. Okay, everyone. Now, when we talk about 10.1 homework, how many of you solved this? Tell me, guys, how many of you solved this? Raise your hand. I hope that most of you have solved it. Wes, Pradyuman, Ronak, Samya, Siddharth, Shrihari. Hi, yes, I'm recording the class. Don't worry, I'm recording the class. Okay, that's why I'm not starting any other topic because many people are traveling today. Okay, right? So I'll discuss each problem. Okay, don't worry, I'll discuss each problem one by one. So if you have any doubt, please ask. And I hope that all of you have solved these problems, right, everyone? Okay, so question number one, let's go through question number one, right? A 50 kg gymnast balanced herself on a single toe, okay? Assuming the toe to be circular with diameter this. Now area given, force given, we can find the pressure, easy, right? Got it? Right? Easy. Now, next question number two. In a hydraulic lift, see, question number one is of boards level. Okay, these kind of questions, right, is boards level, basic formula putting getting. Now, in a hydraulic lift used at service station, the radius of large and small piston are in the ratio. Okay, right? So radius ratio is given. It means area ratio given, right, everyone? What mass placed on small piston will be sufficient to lift a car of mass this kg? Now tell me which concept is used over here? Tell me, guys, anyone, which concept is used over here? Tell me. Yes, very good, right? So pressure throughout liquid is not diminished. Okay, right? So I can use this now. F1 by A1 is equal to F2 by A2, right? Easy. So F1 by F2 is equal to A1 by A2. Now ratio of radius given. So ratio of area we can find. Then force we can find. Easy. So this is also easy. Now third one. Okay, third one. A vertical pipe supplies groundwater to all the floors of a building. The pressure in the water pipe on the ground floor is given. Okay, pressure at the ground floor. Calculate the pressure in the water pipe on the first floor at the height 3 meter. Now, this is based on rho GH. Yes or no? Tell me. Yes or no? Okay. So, yes. So, can I say that? So, what, and this is height H. So, I can say that PB minus PA is equal to rho GH. Right, everyone? Okay. And pressure at B is given. So I say opposite, because A, right, B will be more, na? Pressure at B will be more, right? So PB is PA plus rho GH, but PB is given. You have to find PA. So what is PA? PA is PB minus rho GH. Got it? Easy? Okay. So third, easy. Now fourth one. Abhiram, Shrihari, Wes, Siddharth, if you have any specific doubt, you can ask. Otherwise, I'll just discuss the concepts of every problem. Okay, so that you can solve. Now, fourth one, Torricelli's barometer used mercury. I hope all of you remember Torricelli's barometer. Pascal duplicated it for French wine of density this. Determine the height of the wine. Now, instead of mercury, they used French wine. Okay, right? Got it? So we know that pressure is rho GH. So for mercury, we got 1 atm as 76 centimeter, na? Yes or no? Right? So pressure we will calculate as atmospheric pressure. In bar it is 1.01 into 10 power 5. Yes, right? And instead of mercury, I'm using this French wine with density this. So use this, you will get the height. That's what it is asked, right, everyone? Okay. And actually this happened. Okay. So when you see the videos of discovery of barometer, okay, so instead they use different liquids, right? So the height of the column was very high because of the density. Okay, now fifth one, a hydraulic automobile lift is designed to lift a car. Okay, again this is based on F1 by A1 is equal to F2 by A2, right? Okay, now six, the pressure at the bottom of tank for water is 3p. So at the bottom of the tank it is 3p, and p is the atmospheric pressure, which means, right, the difference is of 2p. Yes or no? Difference is of 2p. So this 2p is because of height of the liquid. Okay, if the water is removed till the level of water is 1/5 of the original. Okay, yes, Aviram. So I can say that rho gh, just think about it, rho gh is 2p. Yes or no? Because atmospheric pressure is p and bottom of the tank 3p. So the difference is because of the height of the liquid. Okay. Now, if water is removed till the level is 1/5, means now h dash is equal to h by 5. Can you find pressure? Tell me. I hope this is easy. I hope all of you can find it. Right? Just divide by 5. You'll get the answer. Simple. Right, everyone? So new pressure will be what? Tell me, new pressure will be what? It will be P plus this, right? And if you calculate this, it will be what? It will be 2P by 5. So P plus 2P by 5 will give you what? Tell me, 7P by 5. Yes or no? Tell me, guys, yes or no? Okay? Yeah, very good. Now, seventh, I hope all of you can solve seventh. Same, right? Two liquids. It is filled with two liquids, oil as well as water. Okay, so rho G, rho 1 GH1, rho 2 GH2. You can calculate. Now, 8.1. Let's see question 8. A U-tube container with water and oil separately by mercury. Okay. Now, I hope all of you remember this question. Tell me yes or no. Tell me, guys. We have solved a problem like this. Exact problem like this. The only thing is the data was changed. Right? So we have mercury and this layer of oil and water. Yes. So this is the same problem. This is the same problem. Okay. The only thing is data is changed, right? So you just have to take one level and make the pressure equal. Okay. So that is the concept of question number 10. Now question number cube having an edge of length 10 centimeter. Okay. Floats in water in such a way that it is partially in water and partially outside. Now, I hope all of you can solve this. This is based on buoyancy, right? Buoyant force. So I can say that, right? This mass into G is equal to density of liquid into volume displaced into G. Yes, GG cancel, right? Density of liquid is what we know. So volume displaced I can calculate, right? I can calculate the volume displaced. Okay, right, Riya? Very good. Samya, Akshaya, Anamika, Shreya. Sania, all of you getting this? Okay, very good, Ria. Now, so question number 9. Now, when you talk about question number 10, okay, question number 10. Think about it. What fraction of an iceberg lies beneath the surface of the sea, right? Now, same problem, same concept. Yes or no, same concept. Okay. Yes, right? So it's just the, yes, it's just the density. So we will use the same concept of buoyancy. I hope all of you remember, right? That this mass will be what? Rho into rho1 v1g is equal to rho2 v2g. Okay, right? Tell me, yes? Mass of the ice is equal to mass of the what? Water displaced. Okay, right? So we can just take the ratio and calculate. GG will get cancelled. Okay, very good. 11th one. A cork of density 250 kg per meter cube floats in a liquid. Again, these all are based on buoyancy. Same as 9th and 10th. 12th. A plastic sphere floats in water with half of its volume submerged. So volume displaced is given, right? Okay. Now this same sphere floats in oil with 2/5 of volume submerged. So this is V1. Suppose V1 and this V2 is 2/5, right? Determine the density. So easy, right? Rho1 by rho2 is equal to, tell me, V1 by V2. Yes or no? Yes or no? Raise your hand, everyone. I hope all of you remember this concept. Yes? Okay, very good. Now, question number 13. Question number 13. So these all are very basic questions depending on the concepts, formula putting, getting types. Now, a metal ball of 160 gram lies in the equilibrium inside a glass of water. The ball touches the bottom of the glass, okay, at a single point, at this point. If the density of metal is given, find the normal force exerted, right? Normal force exerted. So we know that mg will be down direction, right? Yes or no? And then the upward force will be what? Buoyancy. So I can say that normal plus buoyancy is equal to mg. Right, everyone? Tell me, right? Yes. So normal is mg minus buoyancy. Easy? Got it? Okay. Okay. So I hope all of you, those who have tried question number 1 to 13, were able to solve all the questions. Okay, because these questions are not difficult, right? These are your NCERT level questions. You can find these kind of questions in NCERT. Okay, so these kind of questions will be asked in your exam also. Your school exam also you can be asked these kind of questions. Okay, I hope the basic idea about buoyancy, right, Pascal's law is clear. Right, everyone? Okay. Now let's start level 2. So how many of you attempted level 2? Tell me, how many of you attempted level 2? Uvesh, Srihari, Akshaya, Riya, attempted level 2? Yes? Okay, very good. Right? So I'll just give few minutes. Okay. Now question 14, right? Question 14. At least just go through the problem. Okay, just go through the problem. Okay, let's see this. So a large U-tube of uniform cross-section area of 1600 centimeter square is filled with water, okay? If a piston is fit into one of the arm with an 80 kg, right, was standing on it, find the difference in the level of water in the two tubes. Now, if you think about it, this is totally based on the concept of, tell me, Pascal's law. Yes, that the pressure will be undiminished. Yes or no? Tell me, guys. So this pressure difference, right, will be created by this. Okay, buoy of weight 80 kg. So I can say that the pressure difference because of the buoy will be what? Mg by area, right? And this mg by area will be responsible for the change in the liquid level. Yes or no? Tell me. Suppose we have tube like this. Okay. Now a buoy is here. So this will leads to change in the level of liquid over here. Right? The liquid will go up. Yes or no? The liquid will go up. The level of liquid will go up over here. So this is equal to rho gh. Got it? Easy, right? So this is also the basic concepts. Now, 15. Let's go through 15. In a simple hydraulic press, the cross-section area of two cylinders are this and this. Okay, right? A force of 20 Newton is applied in the smaller plunger. What is the pressure produced in the cylinder? Guys, I hope all of you can solve question number 15. Yes or no? Tell me. Yes or no? This is same as the problems, some problems that we have done in level 1. Okay. Yes, very good, right? Okay. Now, 16th. Okay, 16th. During blood transfusion, the needle is inserted in a vein where the absolute pressure is given. Okay, so this is your absolute pressure. Okay, this is your absolute pressure. Now, at what height must the blood container be placed so that the blood may enter the vein? Now, the density of blood is given. Think about it. Density of blood is given. Think about it. Right? But you must be thinking that rho gh is equal to this P. But when we talk about atmosphere, okay, we have atmospheric pressure also, na? Yes or no? So P naught plus rho gh will be P. Agree? Tell me. And this is given. P naught we know. Can we calculate H? Okay. So first done. Now second one. A patient whose blood pressure is high, okay, the blood pressure is high, needs a blood container to be kept 5 centimeter higher than the usual. What is the gauge pressure? So I hope all of you can calculate this. Tell me. Yes or no? Tell me, guys. So from here you can calculate height now. Now, new height will be what? New height will be 5 more than this, right? So H plus 5 will be new height. Okay, so you can calculate the gauge pressure now. Gauge pressure is just rho gh. Yes or no? Okay. Okay. Now 16 done. 17. The density of air near Earth's surface is given. Okay. Just try to understand the problem, right? And atmospheric pressure is given. Okay. Atmospheric pressure P naught is given, and density of air at the Earth's surface is given. If the atmosphere is assumed to have uniform velocity, density, same as that observed on the surface of the Earth, what would be the height of the atmosphere to exert the same pressure, right? Now think about it. Think about it. If the atmosphere is assumed to have uniform density, same as observed at the surface of the earth, what would be the height of the atmosphere to exert the same pressure? So it is just P naught is equal to rho GH, na? Tell me, yes or no? Yes or no? Right? As simple as that. Okay? Yes. Okay, very good. Now, 18th. A copper piece of mass 10 gram is suspended by a vertical spring. Okay, think about it. We have a spring and a mass is suspended, right? The mass is 10 kg. Now, the spring is elongated 1 centimeter over its natural length. So, because of this mass, right, I can say that because of this mass mg, the elongation is given as 1 centimeter. So, kx is given. Okay, step by step, right? Whatever is given, write down step by step. Now, a beaker containing water is now placed below the piece so as to immerse the piece completely in water. Now, this is kept in the container, right? And this is completely immersed in water. Find the elongation of the spring. Now, in this case, we will have a buoyancy, right? We'll have a buoyancy force in upward direction, mg in downward direction, right? And the elongation will be different. Yes or no? Tell me, yes or no? Think about it. So same as normal, don't you think that same as normal, because kx in this direction, right? Buoyancy is also this direction. So I can say that kx dash plus buoyancy will give you mg. Got it? Now your question should be, sir, k is not given, right? K is not given. That's why this information is given, right? K is not given. That's why this information is given. You can calculate k from here, no? K will be what? Mg by x, because this information is already given in the first line. So you can calculate x dash, right? Everyone, tell me yes or no, right? Can you calculate? Yes, very good. Okay, very good. Now, 19. A glass topper weighs 2.5 gram in air, 1.5 gram in water, and 0.7 gram in sulfuric acid. Right? Makes sense, na? So this is just because of buoyancy, right? Okay, yes or no? So density of an acid, density of an acid. So we can just take the ratio, right? We can just take the ratio, na? Yes or no? 2.5 gram in air. So this is normal mg. 1.5 gram in water. So mg minus buoyancy, right? Is this m dash g? Got it? And now again this. So now if you think about the buoyancy, right? If you think about the buoyancy, right? It depends on the density of acid. Okay, right? Yes or no? Tell me yes or no. Yes. So I can say that mg minus b1 buoyancy due to water will give you m2g. Okay. And again, in this case, you will get the same thing. Mg minus b2, or write down m1g, will give you m2g, which is this. Right, everyone? Now you have two equations. So why two equations? Tell me, why two equations? Because you have two variables, no? We have two variable. Volume is also not given. Okay, right? And density of acid you have to calculate, right? Because we already know the density of water. So from here, from this equation, right, you can find the volume. Yes or no? Tell me from this equation. Mg minus rho of water, volume displaced, G is equal to M1G. So Gg cancel. V is this 2.5 minus 1.5. divided by density of water will give you volume. Now, after finding the volume, you can find the density in the same way, right? Right, Ria? Imba? Akshaya? Karishma? Sania? Ronak? Sai Smriti? Samya? Tulip? Okay, very good, Imba. Now, 19th, till question 19th, we have discussed. Now, question number 20. Now, think about it. This figure is given. Okay, so let's try to find the free body diagram. Okay, now read the problem first. A cubical block of wood of edge 3 centimeter, given, floats in water. The lower surface of the cube just touches the free end of the vertical spring. I think we have solved a problem like this, yes or no? Right? How many of you remember we have solved a problem exactly like this? Right? The lower surface of the cube just touches the free end of the vertical spring at the bottom of the pot. Find the maximum weight that can be put on the block without getting. This same question we have already discussed, right? How many of you remember this, guys? Tell me. How many of you remember this? Anyone remember that we keep this mass, right? Small mass. This mass is capital M. So I can calculate, right? So downward force is because of this. Okay, capital Mg plus small mg. Okay, this is the downward force. And upward force will be because of buoyancy plus kx, spring force, right? Right, everyone? Yes or no? Tell me, yes or no? Can you calculate it? Tell me, guys, can you calculate? Okay, very good, right? So you guys can calculate. Now, 21. A body of density rho is dropped from height height h into the lake of density sigma, where sigma is greater than rho. Okay, sigma is greater than rho, right? What does that mean? Tell me. If sigma is greater than rho, what does that mean? Tell me. Yes, floats, right? Neglecting all the forces other than buoyancy and gravitation, right? But since it is dropped, it will have some kinetic energy. Yes or no? Tell me, right? So it will have some acceleration. Agree? Right? Because it is dropped at the height h. Now, think about it. Suppose this is a body and it is dropped. The only force which is acting on this body is mg. Okay? Right? Now, this is hitting this lake surface. If it is hitting the lake surface, I can say that the velocity at this point is nothing but root 2gh. I hope all of you already know the velocity will be root 2gh, right? Okay. Now, at this point, it is root 2gh. So that is the initial velocity. That is the initial velocity. Now, when we talk about this object, okay, because of the velocity, it will go down. Yes or no? Right? It will go down unless and until the acceleration, right, or the velocity becomes zero. Right, everyone? So first we have to calculate what? Acceleration. Now, if you think about this object in water, think about your object in the water, I can say that, okay, mg, downward direction, buoyancy, upward direction, right? And this will leads to acceleration or basically deceleration, right? Yes or no, right? So I can say that buoyancy minus mg will give you ma. I've already considered the direction of acceleration in upward direction, which is your retardation, right? So from here, can you calculate a will be b minus mg by m. Anyone have any issue till this point? Tell me, anyone have any issue till this point? No? Okay. Now, if you imagine, just try to imagine this, right? You don't have to just think about the equations. Whenever you do something, I hope all of you have done something like this, right? You drop something in the bucket and it goes down, then it comes up. Yes or no, right? So I can say that when it goes down, at one point, it becomes stationary, right? The velocity becomes zero. Okay. So V is zero. Now let's think about it. You got U, you got V, you have acceleration. Can't you find H? Tell me, can't you find how deep it will go before coming up? Think about it. Yes or no? Yes or no? Yes? Okay. Very good. Okay. So I hope all of you can solve it. Now, last question is 22 that we are going to discuss from this. Now, two blocks A and B floats in water. Okay, we have two blocks A and B, right? It is observed that A float with half of volume immersed. So half of the volume of A is immersed, and B float with 2/3 of its volume immersed. So this is 2/3 immersed, right? What is the ratio of density of A and B? Again, same, don't you think? Right? It's easy. Rho 1 by rho 2 is equal to V1 by V2. As simple as that. Right, everyone? Tell me, right? Okay. Okay. Now, anyone have any doubt? See, question number till question number 22 should be solved by everyone. Okay. Anyone have any doubt till this question number 22? Tell me, guys.